So welcome to the third class of polynomial. So in earlier classes we have discussed the polynomial, the quadratic equation, its zeros, relation with coefficients, and today we will discuss division algorithm for polynomials. Means we know division and algorithm. Algorithm means it is a step-by-step procedure. Okay, so division algorithm means it is a step-by-step procedure for polynomials. So division algorithm indirectly it is a detailed analyzed very simple steps through which we can divide a polynomial with another polynomial, and Euclid's division lemma is also applied here. So what is Euclid's division lemma? For any integer a and b, there exists unique integers q1 r. So a equals to bq plus r. In indirectly meaning we can say dividend equals to means a equals to bq means divisor into quotient bq plus r remainder. Okay, so in other words we can say for a given polynomial, so polynomial px, here px means please keep in mind, for a given polynomial px, just like there a is dividend, here px polynomial is dividend, and gx another polynomial that is divisor. In that case that was b. A and b are two integers, here a and b are two polynomials. So px is a polynomial, gx is a polynomial. There exists another two polynomials qx and rx. Qx is quotient, rx is remainder, and here x means these are the polynomials. Okay, so if you will divide a polynomial with another polynomial, you would get a quotient as polynomial and remainder also as polynomial. But the point is, as there we are discussing a is always greater than b. Here also polynomial. So here polynomial greater means the degree. Here degree of polynomials means degree of dividend is always greater than degree of divisor. Okay, and next what about remainder? So remainder there is always less than or equal, sorry, the remainder is always equals to 0 or greater than 0. So here is also remainder is 0 or greater than 0, and less than, there it is less than the divisor. Here less than divisor means less than the degree of divisor. So in other words, in simplified way I can say here px and gx are two polynomial, px is the dividend, gx is the divisor. So there is a quotient, there is also a remainder. So always the degree of px is greater than the divisor, and the degree of remainder is less than the divisor. Also remainder may 0. Now we will discuss the exact steps through which we can divide a polynomial with another polynomial. I also discussed this very clearly in class 9. Again I will follow the same steps. So the first step is arrange both the px and gx, means the dividend and divisor, in the decreasing order of exponent. Means we will arrange the polynomials in a decreasing order of their powers and exponent. For example, first is cube, then is square, then is x, then is the constant. In the question it may be not in arranged one, but we will make it arranged. And the next one, check the first term of both dividend and divisor. After arranging, then we will check the first term of divisor as well as the first term of the dividend. Then we will try to write something in the quotient, so that the quotient will be multiplied with the first term of divisor to get the first term of the dividend. Means there are many terms, but first we will focus on the first term. After make it correct the first term, automatically others will be correct. And when we will check, first we will check the coefficient. What is the coefficient or symbol? What is along with the coefficient, along with the symbol, or you can check first the symbol then the number. So first we will check, for example, the first term of the dividend is 3x square, and the first term is of divisor is 3x. So the coefficient of divisor is 3, coefficient of dividend is also 3. So they are same, also their symbol is same. So there is nothing to do with the coefficient. Now we will move through the variable. So the first variable, first term, the variable is x in the divisor, and the variable of the first term is x square in the dividend. So what I will multiply with x to get x square? It is x. So I will write x in the quotient. So again I am revising, please listen it carefully. We will check first terms of dividend and divisor, means px gx. So then I will write something in the quotient, then that means I will multiply something with the first term of divisor to make it equal to the first term of the dividend. So there are two things in a term, that is coefficient and variable. So first I will finalize the coefficient along with the symbol and then variable. Okay. So by this we are getting a term in the quotient. So we have multiplied that quotient with the first term of dividend, but there may be other terms in the dividend. For example, the dividend may be x plus 3. So I have multiplied with only x, then I will also multiply with 3. Again, first you find the check the two terms, means first term of dividend and divisor. Then you multiply something with the first term of divisor, so that your first term of dividend will be same. After making it same, you got one term of quotient, you have to multiply it with the entire divisor. Already we have multiplied with 1, then you can multiply with all the remaining terms, then you will get one expression, then it will minus it from the divisor. As usual process, you are dividing 10 with 3, then 3 into 3 9, then we are subtracting 9 from 10. Similarly here also we will subtract. So here subtraction means we will only change the symbol. Okay. So after changing the symbol, we will subtract, means we will finalize what is the remaining part, and then we will check if the remaining part, means the remainder, if the degree is less than the divisor, then it is completed. If not, then we will follow. Again I am saying, in the previous case we are checking the remainder, is it less than divisor or not. So here always we will check, is the degree less than or not. If the degree is less than the degree of the divisor, then the division is complete. If it is greater than the divisor, then again we will follow the same process. From step 2, again we will, if the remainder degree is greater than the degree of divisor, again we will repeat from the step 2. Look here, division algorithm clearly mentioned in your book. If px and gx are any two polynomials with gx not equals to 0, then we can find polynomial qx and rx such that px equals to gx into qx plus rx, where rx equals to 0 or degree of rx less than degree of gx. So this result is known as division algorithm. This is nothing but the dividend equals to divisor into quotient plus remainder. Okay, now we will do one question example as given in the book. So the example is divide 3x square minus x cube minus 3x plus 5 by x minus 1 minus x square. So first we will arrange all them in the decreasing order of exponent. It is clearly written, check in the right side, minus x cube plus 3x square minus 3x 5. So everything arranged in the decreasing order of their exponent, also in the divisor minus x square plus x minus 1. So here we will check the first term of the divisor, this is minus x square, first term of the dividend is minus x cube. So symbol is minus, minus, correct. Next we will check the coefficient, it is 1, 1, correct. Next the variable x square, it is x cube. So what I will multiply with x square to get x cube, this is nothing but x. So in the quotient it is written x. So as I have said, whatever I am writing quotient, that should be multiplied with all the terms of the divisor. So I have multiplied it with only one term, that is x into minus x square minus x cube. Then x with x, x square, x with minus 1 minus x. Then I will subtract. Subtraction means nothing but the changing of the symbol. So I have changed the symbol, then again the remainder I am getting. So here the degree is 2 and the divisor degree is 2. So 2 is not less than 2. It is equal but not less. So I will continue till it is less. So again we will check the first term is 2x square, the first term is minus x square. Here the symbol is minus, but in the divisor it is 2x square plus. So minus plus. So what will be multiplied with minus to get it plus? It is minus. So it is written minus in the quotient. Look on the top part, x then minus. Then here coefficient is 1, here coefficient is 2. So 1, how much will be multiplied with 1 to get to it is 2. Okay, then it is x square, it is x square, correct. So no variable will be multiplied. So the final term is minus 2. Now so I got the term minus 2. it should be multiplied with all terms of the divisor. So minus 2 into minus x square plus 2x square minus 2 into x minus 2x minus 2 into minus 1 plus 2. Then I will change the symbol and the remainder is 3. So here the degree, or I can say the highest power is 0. Why? Now every constant's degree is 0, means 3 equals to 3 into x to the power 0, 3 into 1. So here the degree is less than, so it is completed. So the quotient is x minus 2 and the remainder is 3. Then I can write the division algorithm. Dividend means the polynomial equals to divisor, that is x square minus x minus 1 whole into quotient, that is x minus 2 plus 3. So if I will also multiply this, and definitely I will get the dividend, that's written here. Then we will solve one example, that is example 9 of ncert book. So 2 zeros are minus root 2 and root 2. Okay, then find all the possible factors of the given polynomial. So now we will solve it. Solution. So there are 2 zeros, root 2 and minus root 2, and we know if root 2 is a 0, so what will be a factor? Think, pause the video and think. If root 2 is a 0, dash is a factor. If a is 0, then dash is a factor, x minus a is a factor. So if root 2 is 0, then x minus root 2 is a factor. Definitely if minus root 2 is a 0, then it's opposite, x plus root 2 is a factor. So clear? Now you got two factors of the polynomial. I have not written the polynomial here, it is in the book. You can check the example from your book. So here you got one factor is x minus root 2 and another factor is x plus root 2. Okay, now you imagine 18 has many factors, 2 is a factor, 3 is a factor. So if you are multiplying 2 and 3, 6 is also a factor or not? Because we are writing 18 as, we will factorize it 1 into 2 into 3 into like this, prime factorization method. Okay, similarly it is a factor, means we can factorize the polynomial something into something into something. Okay, so as one part is a factor, so their product is also factor. Just imagine, you don't think that, sir, if 3 is a factor and 9 is a factor, then 3 into 9 is 27 a factor of 18. No, it is wrong. But my concept is little bit different. I am saying it is written as the products. So here factorized form means you are writing x cube minus 3x square plus 8x plus 10, whatever the polynomial. So here factorized form means you are writing x plus 2 into x minus 3 into x square plus 3x plus 2. So here you are factorized the entire polynomial as the product of three things. So my concept is, if you multiply two things, so first two are multiplied, then third one is remaining. So the product of the first two things is multiplied with something to get the polynomial. So definitely the product of first two things is also a polynomial. On that aspect, x minus root 2 whole into x plus root 2, their product is also a factor. And if we put the formula a plus b into a minus b, it is nothing but a square minus b square. So it is x square minus 2. So it is also a factor. So till now it is two factors are given, sorry, two zeros are given, root 2 minus root 2. So I said x plus root 2 and x minus root 2 are factors. So their product is also a factor. Now imagine, so as the product is a factor, then it is multiplied with something to get the polynomial. For example, if 6 is a factor, then 6 is multiplied with something to get 18. So 6 is a factor. Are you getting the concept of factor? Why 6 is a factor? Because 6 is written as the product of something to get 18. So 6 is a factor. Then I am asking, what is the other factor? Then simply you can say, as 6 is multiplied with something, 6 is a factor. Then that something is also multiplied with 6. Then that something is also a factor. Okay. Then 6 into something equals to 18. So 6 is a factor and something is a factor. Then we think how you can find that something's value. Imagine 6 into something equals to 18. So what is the value of that something? It is nothing but 6 is divided with 18 and it is 3. 6 into 3 is 18. 6 into something is 18. So that something is also a factor. And how to find that something? That is polynomial divided by the pre-existing factor. So already we calculated x minus root 2 and x plus root 2 to get x square minus 2. As x square plus minus 2 is a factor, then x square minus 2 into something equals to the polynomial. So what is that something? The polynomial divided by x square minus 2. So, whatever I will get in the quotient, that is a factor, and if I can further factorize that quotient to get the other factors. Just for example, 18 by 6 I am getting 3, I can write 3 equals to 1 into 3 for example. Similarly, 1 is a factor, 3 is a factor. So, whatever you are getting in the quotient, also you factorize that if possible. If not possible, okay, that is a new factor we are getting. But if that is a factor, if that is further factorable, we should factorize it. Okay. So, this is all about this question. So, zeros, I am summarizing the steps. Zeros are given. So, find its factors, then multiply the factor to get a new factor, and what are you getting as a factor, divide it with the polynomial. So, the quotient is also a factor. If possible, we can factorize the quotient also. Now, we will move to the last exercise 2.3. Check the question. Divide the polynomial px by the polynomial gx, find the quotient and remainder. As already discussed from the book example. So, you take px as dividend, gx as the divisor, arrange them according to the decreasing order. I think maximum are already arranged, then follow the as usual steps. Question number 2, check whether the first polynomial is a factor of the second polynomial by dividing the second polynomial by the first. Okay, is the first a factor? Is 2 a factor of 18? How you are checking? 18 by 2 is 9, the remainder is 0, so a factor. So, take the first one as gx and the other polynomial is px. So, write the second polynomial in between and the first polynomial as divisor, then follow the as usual steps as question number 1. If you are getting the remainder 0, yes, it is a factor. If not, no, then it is not a factor. Then we will check the question number 3. It is nothing but the same as I have discussed the example 9, the exact same steps. Try this question yourself. Okay. Now we will come to question number 4. So, question number 4 is very easy, but it is important to understand the wordings. So, please read it. On dividing this, means this is polynomial, try to understand. Dividing this, divide 18 by 2. So, 18 is the polynomial, 18 is the dividend. So, dividing this means this is the dividend px, a polynomial gx means a polynomial gx, gx means the divisor, it will be in the left side. The quotient and remainder where x minus 2 means here the quotient is written first. So, the quotient is x minus 2 and the remainder is minus 2x plus 4 respectively. So, find the value of gx. If I will analyze the question indirectly, the value of px, qx, rx is given, simply gx is asking. So, first I have to think of the relation between px, gx, qx, rx, that is either you can say Euclid's division lemma or division algorithm. Okay. So, we know px equals to gx into qx plus rx. What is asking? Gx. So, I will keep gx in one side and take others, all others to the other side by step procedure. So, first there are two terms, I will separate the unrequired term. So, gx with the term associated with qx, they are multiplied. So, I will take rx to the other side and I will subtract that. Okay. Now, gx into qx equals to px minus rx. So, what is gx? Then qx is multiplied, other side it will be subtracted simply. Now, gx equals to px minus rx divided by qx. Okay. Simply I will put all the values here and I will get the value of gx, x cube minus 3x square plus x plus 2. It is px minus of, in bracket there will be remainder x. So, what is remainder? That is minus 2x plus 4. So, by subtracting I am getting x cube minus 3x square plus 3x minus 2 divided by the qx quotient is x minus 2. Now, if I will divide this, definitely I will get gx. How I will divide it? Now, I will take that x cube minus 3x square plus 3x minus 2 as the dividend and x minus 2 as quotient. Whatever value is there, that is gx. Next, we will go to question number 5. So, question number 5, it is also very easy. Again, we have to be careful to understand the wordings. So, here if you read the question, give examples of polynomial px, gx, qx, rx which satisfy the given. Means in first case, px and qx relation is given. Okay. So, we will take px and qx anything, but they should be same and you have to find out your gx and remainder Rx. Similarly, in second case, relation between Qx, Rx is given. So, whatever you may take Qx and Rx, they should be same, but you have to find Px and Gx from your side. So, in third case, remainder x is given 0. So, you may take anything Px, Gx, Qx, but Rx should be 0, and we will come to the first bit. So, in first bit Px, Gx should be same. So, I have taken a very simple example. So, Px let it be for small cases. So, here Px and Gx are same. So, I have taken them as 5. I can take any value. You take any value, but that should satisfy the given equation as well as the division algorithm or Euclid's division lemma. So, I can take 5 and 5. So, what will be quotient you think? If 5 is Px, if 5 is dividend, 5 is divisor, 5 is divided with by 5. So, what will be the quotient? It is definitely 1. What will be the remainder? It will be also 0. Okay. So, in right side I have taken the example of a polynomial. So, I have taken the polynomial x plus 1. So, according to the question Gx will be same. So, Px is x plus 1, Gx is x plus 1, means your dividend and divisor are same. So, if they are same, so what will be the quotient? It is always 1. Any number is multiplied to what? Get the same number. So, if I will get again the same number, what will be the remainder? It will be 0. So, I have written here Px equals to Gx into Qx plus Rx. Okay. So, if your Px and Gx I have tick marked, if they will be same, when? First thing, your R should be 0 and Q should be 1. If Q is 1, then Px equals to Gx into Qx, that will be 1. So, Px equals to Gx plus Rx. If that R will be 0, in the second question, it is given Qx equals to Rx, means your quotient and remainder will be same. You have to find out Px, Gx. So, I have written Qx equals to Rx. So, for example, I have written the quotient as 3, the remainder as 3. So, you take anything in the dividend and divisor, no problem, but my remainder should be 3 as well as the quotient should be 3. So, you think this is 3, this is 3. So, I can write in the divisor anything. If I will write the divisor as 5, then it will be the, what will be the dividend? It is quotient into divisor, 3 into 5, 15 plus 3, 8. Okay. If I will write the divisor 4, 3 into 4, 12 plus 3. So, the dividend will be 15. If I will write the divisor as 10, then 3 into 10, 30 plus 3, 33. Are you getting? You may get multiple values, but whatever you have to make fixed, you make that fixed. That is your quotient and remainder to be same. So, quotient 3, remainder 3. So, do not write anything in the dividend, it will lead to misfortune. Okay. So, write first the divisor. So, it is 3 into something plus 3, you will get the dividend. If you write 100, then 3 into 100 is 300 plus 3, write the dividend as. And now we will do it for polynomials. So, I said the remainder and the quotient are same. So, here in the remainder I have written x plus 2. So, in the quotient also I have written x plus 2. Then you take anything in the divisor. Suppose the divisor, you will write in the divisor, for example, I have written here 3. So, if you write in the divisor 3, so what will be the dividend? It is quotient into the divisor. So, it is 3 whole into x plus 2, that is 3x plus 6, then plus remainder is x plus 2. So, this is 3x plus x, 4x, 6 plus 2, 8. If you write here 5, no problem, you can try with 5. So, 5. So, if you will write 5 as divisor, then what will be dividend? 5 whole into x plus 2 means divisor into quotient plus remainder. So, the dividend will be 5 whole into x plus 2 plus x plus 2. So, 5 into x plus 2 will be 5x plus 10, I have written here. Sorry, I am saying it 5x plus 10 plus x plus 2. So, it will be 6x plus 12. I have tried with 3. So, you can take here 3x also, no problem. You can take anything. You can write anything in the dividend. Whatever you will write in the dividend, first multiply that with the quotient, then add with the remainder, then write the total expression in the dividend, that is the polynomial. Okay. Next, we will move to the last bit, that is the remainder 0. The remainder is 0. So, you can try px, gx, qx anything, but I have tried it very simple one. So, I wanted the remainder to be 0. So, I take the polynomial and the divisor to be same, means px, gx same, x plus 2, x plus 2. So, if it is same, so the quotient will be 1 and the remainder will be 0, but you can change it just like in the second case what I have did, the remainder to be 0. So, I have taken x plus 3 at divisor. So, x plus 3 and I have taken the quotient 2. So, I multiplied x plus 3 whole into x 2, that means the whatever I am getting, that is the dividend, because the remainder is 0. So, you can try anything in the quotient and in the divisor, you multiply them and write that amount in the dividend, because the remainder is 0. So, the formula is dividend equals to quotient into divisor plus remainder, as remainder is 0. So, what is dividend? So, dividend equals to quotient. So, dividend equals to divisor into quotient. Any value you can try in the divisor and quotient. So, in total, if I will say question number 5, what is the step, what is to try, what you should do. So, what value, what relation is there, first you take that, just like you put one division symbol I am doing, okay. Whatever value is written you write there, then recall the Euclid's division lemma, okay, or the division algorithm. So, dividend equals to divisor into quotient plus remainder. So, what is same you put it there, automatically you will find the other values. So, clear. So, this is all about division algorithm of polynomials, how to divide polynomials. So, I hope all of your doubts are cleared. So, thank you all. So, this chapter is complete. Thank you.